going to talk about the epsilon definition of a limit of a sequence. This is the same idea of a limit that you grew up with in calculus. It's just much more formal. So I'm going to explain how the epsilons and the big N's and the little n's all relate. So I'm going to do this with a picture first. So my red point here is my A that sequence is going to converge to, and my green sequence is denoted by the numbers. Here's 1, 2, 3, 4 is out there, 5, and then 6, 7, 8, and after that just runs towards that red circle. So 1, 2, 3, 4, 5, 6, 7, 8. So let's see. For all epsilon, here's how the game is played. For all epsilon, so I'm going to pick an epsilon, which is going to be the radius of a circle. So maybe my epsilon will be this radius. That's an epsilon. So I could have picked epsilon to be anything, but I'm picking it to be that. So there is a capital N, such that for all little n after that, my sequence is with an epsilon, is within the circle, basically within the circle is what this says. So what's the capital N? I have to look and find a capital N after which every single thing is inside. Well, 1 is not inside the circle. That's not good. 2 is inside. Okay, so 2 might be the capital N. 3 is in. That's good. Oh, 4 is outside. So 2 cannot be my capital N, because the way I think about this is if 2 were my capital N, that means that all these other things would be little n's, and they would all have to be inside the circle. But notice 4 isn't inside the circle, so this can't work. So let's undo this. So 3 can't be capital N either because 4 is inside. 4 is outside the circle. Oh, but 5 could be, because after 5 you just zip in. So here'd be a good candidate for capital N. And then after these are all my little n's. And for all of these possible values, a sub 6 minus a is less than epsilon, which means a sub 6 is inside the circle. A sub 7 minus a is less than epsilon. That's inside the circle, etc., etc. But this has to be true for all epsilon. So let's look at a slightly different circle. Maybe I want my epsilon to be really tiny like this. Right? So now, what's inside? Well, 1 is not inside. 2, a little bit of 2 sticking outside, so we're not going to count it. 3 is outside. 4 is way outside. 5 is outside. 6 is touching the circle, so we won't count it. 7, though, let's say 7 is inside. That means 7 can be our capital N. And then after that, all of these guys, including 7, have to be inside the circle. And I told you that after that, we just head straight for that. So no matter how small of a circle you draw, you have to be able to find this point, this capital N, where after that point, every other thing is inside the circle. So that's graphically how you think about it, is that no matter how small of a circle you draw, there's always some point, which we call capital N, where every other number, which the little n denotes, is going to be within this epsilon circle, and algebraically that's a sub little n minus a is less than epsilon, as long as little n is bigger than equal to big N. That's graphically. Let's look at an example more kind of algebraically. Let's a sub n be equal to 1 plus 2 plus 1 over n times I. So you can probably tell pretty quickly that this is going to go to 1 plus 2i. In other words, this is going to be my value for a, and these are going to be my a sub n. So how's this game played? Right, for whatever epsilon, I should be able to come up with a capital N. So let's start out relatively easy. You think of it epsilon as being small. If epsilon equals 0.5, well, what do I need? I need 1 plus 2 plus a 1 over n, which is that, times I, minus 1 plus 2i. This has to be less than epsilon. Well, that equals, oh, I get a bunch of cancellation. I'm left with I over n. This has to be less than epsilon. Oh, but that's equal to 1 over n. Oh, so I can just pick n, capital N should be equal to 2. Because if little n is 2 or bigger, I'm going to be less than 0.5, like so. And we can play this game again. If you want it to be equal to 0 plus 1, I need 1 over n less than 0.1. So pick n equal, how about, I don't know, 11. This should actually be 3 because I need to be